Okay, let's try to do 4A. So let's read the question. Okay, so this is chapter 5. So the airplane with a wingspan, wingspan ni bersayap lah, tip to tip, hujung ke hujung, of 42 meter is flying horizontally at a speed of 300 km per hour. So we have value speed 300 km per hour, and then the vertical component of the Earth's magnetic field is B equals to 5 darab 10 kuasa negatif 6T. Okay. And then determine the induced EMF between the wing tips. Okay. So this one is EMF berapa. Okay. So how about the value of 42? Okay. So if you confuse which one so this one is, can you imagine? We have katalah B contoh B into the page contoh. Now katalah kita ada the airplane. Okay, and then dia bergerak with a speed of V kan. So this one is the straight conductor punya case lah kan dalam EMF tu kan. So kalau kamu tengok kat sini kan, this one kan, to find the induced EMF ni banyak formula. Tapi kita ambil untuk straight wire ni lah. So kita ibaratkan our airplane tu in a straight wire. So dia limpas across a magnetic field kan. Take a look over here, we have our B, L and V lah. Okay, so we use this formula to find the EMF, iaitu EMF is equals to BLV sin theta. Okay, so our B is 5 darab 10 kuasa negatif 6. And then actually this is our L lah kan. Kapal terbang tu daripada hujung ke hujung 42 meter. So this is our L. However, we have to change our V lah. Okay, so V ni 350 mesti tukar kepada meter per second dalam SI unit dia lah. So kilo is 10 kuasa 3, meter dah tukar, hour tu kita tukar kepada second lah. So I know that 1 hour is 3,600 second. So sorry, I'm going to put it Miss buat kat sini lah So V is equals to either one the hour, and then I know 1 hour equivalent to 3,600 second. So ni potong. So I think you will get your V dalam meter per second adalah 97.22 ms negative 1. Okay, so please put it here. And then selalunya angle dia 90 lah sebab nak nilai dia sama dengan 1. So your EMF is 0.02 V. Okay. Right. So kita lalu tu kita buat 4B. So let's read the question. Okay. So a coil of 122 turns and a diameter of 0.1 meter, okay, 10 centimeter, 0.1, is placed as a uniform magnetic flux density of 0.25 Tesla, as shown in figure 4.1. So the magnetic flux akan decrease to 0, maksudnya ni B initial, so B final dia akan jadi kosong kan dalam masa 5 saat. So calculate the induced EMF and state the direction of your coil. Induced current. Induced current. Okay. So this one kita tengok list of formula kan. So yang ni yang berubah B kan. Berubah B. So I think we can use this formula. Change B for coil. So I think we're going to use this formula. Okay. EMF equals to NA dB over dt. Set to so dB is actually changes kan, B final minus B initial to time adalah time lah. So negative 120, you don't put negative so pun tak apalah 120, and then your area, kena kira area asing. Area is pi r square, and then diameter kita 0.1. So R akan bahagilah kan, 0.1 bahagi 2. 0.05 meter, so maksudnya pi 0.05 square, isn't it? Okay, so darab dengan pi darab dengan 0.05 square. So your area is actually 7.85 times 10 to the power of negative 3 meter square. So B final is 0. Oh, boleh lah tak negatif supaya cancel dia punya ni kan. 0.25. So put it here. 0 minus 0.25 over time, which is 5 seconds. So I think your induced EMF you get 0.047 volt. Okay. So this one macam mana kita nak tentukan direction of your induced current. So remember, okay, you have to know this. Okay. Kenapa begitu you can ask me personally but this is a recap. Okay. Kalau kita ada induced EMF kalau magnetic flux decrease, so B baru dia adalah in same direction. Kalau magnetic flux increase, dia akan be induced, dia akan jadi opposite. Okay, so this one dalam case adalah magnetic flux is decrease, so B induce kita adalah same direction. So this one B yang asal ni memang dah into the page kan. So maksudnya okay, you will use your hand tau, your thumb ni. Thumb, this is your jari. Sorry, Miss pun tak tahu macam mana nak lukis jari kamu. Okay. Okay. So ni adalah B into the page. Ini adalah fingers ni adalah you punya current. Okay. So kan. So sekarang ni awal-awal B dia lah into the page kan. So the question is kamu nak buat B tu into ke ataupun out. Okay. So kamu tengok kat sini. Kalau magnetic flux decrease, so maksudnya B dia ikut dia yang sama macam dalam soalan ni, which is into the page. So kamu bayangkan kamu masukkan kamu punya thumb tu, ibu jari tu into the page, maksudnya dalam paper. Lepas tu kamu dapat tengok flow of current kamu tu dalam clockwise. Okay. So the answer is clockwise, the direction of your current Sebab yang jari kamu ni direction of current. Okay. So kalau kamu tak nampak, kamu boleh tanya Miss lah depan-depan. Okay. Right. So let's try to do question 4C pula. Okay. Sebab soalan dia agak senang. I mean dia guna formula saja. Okay. So let's read the question. Okay. So 4C. So an air coil solenoid with a 100 turns, 1000 turns, 1000 turns per meter of length, maksudnya 1000 turns per meter ni kan, okay, has a cross-sectional area of 800 millimeter square. So, calculate the self-inductance. So, dia nak L, inductance adalah L. Self-inductance L, mutual inductance M of the solenoid if the length of the solenoid is 500 times 10 to the negative 3 meter lah. Okay. Right. So, how do I do this? So, how to find the L of solenoid? So, I think kita ada formula untuk tu L for solenoid adalah this formula. Mu naught n square A over L. So, this one So, mu naught is a constant. Okay. Ni akan boleh tengok dekat list of constant 4 pi darab 10 kuasa negatif 7. Okay. So, I am going to use that formula iaitu. Okay. So, tak ada space pula. Boleh. So, L is equals to mu naught n square A over L. So, mu naught ni adalah 4 pi constant. Okay, and then area adalah, kalau kamu convertkan area 800 mili kan. Mili adalah 10 kuasa negatif 3 square meter square. So remember meter ni pun square. Semua square kat sini. You want to get 800 darab 10 kuasa negatif 6 meter square. So this one dimasukkan 800 darab 10 kuasa negatif 6 over L adalah 500 darab 10 kuasa negatif 3. Okay, this is a common mistake by student So, N is number of turns. Tapi dia kasih kita number of turns per length. So, how do I buangkan meter ni? So, Miss darab lah dengan another meter lah. Kan, meter dia adalah 500 darab 10 kuasa negatif 3. Panjang wire tu adalah 500 darab 10 kuasa negatif 3. So, Miss kena buang meter tu. Okay. So 1000 darab dengan 500 darab 10 kuasa negatif 3, you get actually your number of turns is actually only 500 sahaja. So this one you have to be careful So this one is 500. So your L, I think you will get 5.03 darab 10 kuasa negatif 4 Henry. Okay. Okay. Right, so that is for C1. Okay, let's try to do C2 pula. So let's read the question. So calculate the average induced EMF in the solenoid if the current in it decrease from 0.8 to 0.1 in 0.05 seconds. So kita ada current initial 0.8A. Current final adalah 0.1A, masa dia ambil adalah 0.05 second. So dia kira induced EMF. Okay, so kita tengoklah ni adalah self-inductance. So apa formula yang boleh kaitkan self-inductance dengan L, dengan EMF dengan EMF dengan L. So this one kan, ni pun ada change of current. So EMF equals to L di over dt kan. Kalau kita susun balik, L tadi dah dapat. Okay, so I think you will get your L tadi adalah 5.03 darab 10 kuasa negatif 4. So I final tolak I initial bahagi dengan 0.05. Okay, so this one you just put negative lah. Sebab nak cancelkan yang ni, kamu akan dapat negatif kan kat sini. The equation also got negative okay. So I think you get your EMF induced adalah 7.04 times 10 to the power of negative 3 volt. Okay.